Hi guys, in this video we're going to be looking at how do we multiply polynomials. So we've already seen how to add and subtract them, now we're going to be multiplying them. So in this first example we have a term out on the outside that's being multiplied because it has those parentheses by everything that's on the inside. So we're going to multiply that outside term by everything that's on the inside. So first we're going to distribute to the first one. So I'm going to go ahead and write this. So it's going to be 3n squared times 2n cubed, and then 3n squared times 4n squared, and then 3n squared times negative 3 by using the distributive property, which we should already know. Now from here we're going to just pretend and take each term as if it was completely by itself so that at the end we can combine everything together. So here I'm going to just say, okay, well, let's pretend this is just multiplying. 3 times 2, that gives me 6. N squared times n cubed. Well, we already learned what to do with our exponent rules. We know that when we have two bases that are the same, that are being multiplied, you're going to add the exponents. So 2 plus 3, and so that would be giving me 6n to the 6th power. Okay, now let's go ahead and do the second one. In the second one we have 3n squared times 4n squared. So 3 times 4, that gives you 12. N squared times n squared. Again, going back to exponent rules, we're going to add the exponents. 2 plus 2, so that's going to give me 4. So it's going to be n to the 4th power. So this would be 12n to the 4th power. And let's go ahead and do that last one. 3 times a negative 3 gives me a negative 9, and then just with n squared. So this would just be minus n squared. And so at the very end I look to see if there's any like terms, anything I can combine. Since they each have a different exponent, we can't combine these. So we're basically done. We have our final answer. Okay, let's go ahead and take a look at this example. In this example, we're looking at multiplying polynomials as an area. So here, if you notice, we have a rectangle, and one of the sides is x plus 5, and the other side is x. So they're wondering, what is the area of this rectangle? So let's figure this out. This is actually a representation of what do you do to multiply x plus 5, sorry. So here's x plus 5, and you would multiply it by the length, which would be x, or the width. So I'm going to split it up and I'm going to do it into terms. X times x, well, that's what I'm doing here. X times x would give me x squared. And then x times 5, so this is a rectangle. We're splitting it up into two rectangles. The blue one, which I already did, has an area of x times x, which is x squared. And now I'm going to split it up. This other rectangle has a length of 5 and a width of x. So if I multiply 5 times x, just like I'm doing here, 5 times x, I get 5x. Now that's the area of the pink rectangle. This is the area of the blue rectangle. But I want total area. So what am I going to do with those? I'm going to be adding. So this would be x squared plus 5x. And if you look at how we would be doing before, x times x is x squared, and x times 5 is 5x. So basically, this is the area model of how we multiply polynomials. And you don't have to use it this way, but you need to understand how it works.